This question is a parity question, and this one, it says the data transfer system will use parity checks. The bytes need to be sent using an even parity byte check. Complete the parity bit for each byte. So 2 marks for that. So if you can remember how to do this, try this at home, wherever you are. Okay, so hopefully you have tried this on your own. You can pause the video at any point. For even parity, we count the number of ones. So we're going to count the number of ones. So for the byte A, we've got 1, 2, 3, 4. That's an even number. 4 is an even number. So we set it to be a 0 because we want to keep that even number. And then for byte B, we've got our number is 0. We haven't got any ones. And 0 is considered to be an even number. So again, that parity bit is going to be a 0 to keep that 0. The second part of the question, a parity block check can be used instead of a parity byte check. Explain how a parity block might detect an error in transmission that would not be detected by a parity byte check. So what they mean is we've got this byte here. If we have an error in this between the sender and the receiver, well, what sort of error could we have? Well, we could have bits transposed, so they could be swapped, or they could be lost. So for example, that could just get turned into a 0 for some reason, in which case our count would be 3 instead of 4. So because we've got an odd number, that's going to be, it's going to be detected. But the problem is that we don't know where the error happened. So that is the kind of the key thing between a parity byte check and a parity block check. So basically what we have is we also have, we have our parity bit here, but we also have a parity byte. So the parity byte will be on the end here in our block. We'll have more than 2 normally. Normally there'll be a lot more in our parity here, but because we have the byte, that will basically be just a complete check. In this case, that would be a 0. Sorry, no, that would be a 1. That would be a 1. That would be a 0, 0, 0, a 1 and a 1, because we're adding up columns. So that would be 2. That one would be 2, etc. Okay, so I'm going to type this in because my handwriting always looks really messy on this. So we say a parity byte is added to the block, and this will help us identify which bit in which column and byte i.e. the bit and byte where the error occurred. So a parity byte is added to the block, and this will help us identify which bit in which column and byte where the error occurred. So for example, if we have a lot more columns in it, or just say we've just got these 2, just for argument's sake, and we know that the parity, so we would have the byte there, as I said before, the parity byte, and we have an error, for example, here, we would know that it was this byte here, for example, this column and this byte where the error occurred, and therefore we would say that that should be a 0. That's what the byte does.